Even uh, Sakshi, Rachita, am I audible? Audible?
Yes, ma'am.
Yeah. Let us wait for some more participants before we join in the technical session. But since this is the last day of the FDP, I would like to know if somebody wants to share anything and about the content and the presentation of the speakers, anything. They can either put up in the chat or they can just raise their hands. And I'm sure all of you must be adhering to the guidelines which has been given to you time by time, which includes basically logging in into the for the sessions through your registered email ID.
I'm sorry to interrupt. Your voice was coming bit low.
Okay. Is
Yes,
it
ma'am.
okay now? Is it okay
Now
now?
also it's little low.
Okay. Is it all right now?
Yes, ma'am. Yes, ma'am.
I guess there is some problem with the headphones. I was using the headphones and maybe its mic is not working. Yeah, I was telling, uh, in case all the participants, they have any issues or any feedback regarding the FTP, they can share it now. Or maybe one thing I would like to ensure that all of you are, logging in through your registered email IDs. If anyone has any query, any doubt, or anything to say, they can either raise their hands or they can put up in the chat box. And I think it's already 10:10 now, Sakshi. We can start with the session. Other people will
Sure, ma'am.
join in between.
Yes, ma'am. Sure.
Good morning, everyone. On behalf of Indira Gandhi Delhi Technical University for Women, I feel privileged to extend my warm welcome to all present here. Today's talk will be presented by Professor Nidhi Goyal. Professor Nidhi Goyal is the head of the Department of Electronics and Communication Engineering at Indira Gandhi Delhi Technical University, New Delhi. She has teaching and research experience of approximately 20 years. She received her BE degree in Electronics and Communication and MTech degree in Digital Communication in 2001 and 2006 respectively. She pursued her research interest and completed her PhD from IIT Roorkee. Her areas of interest include medical image processing, deep learning, artificial intelligence applications, multimedia security, computer vision, and soft computing techniques. She has published 4 book chapters and over 65 research papers in reputed international journals and international conferences. Over to you, Nidhi ma'am.
Thank you, Sakshi. You need to tell me if I'm audible now or this is again creating a problem.
Yes, ma'am, you're audible.
All right. Thank you, Sakshi. Yeah. We'll start with that session today, but can anyone tell me I had handled one more session on day one. Can anyone tell me if they remember anything from that session where I stopped and what did we discuss? Okay, I'll give a quick brief of whatever we have discussed on day one, and we will continue there on today after that particular slide. So when I took the lecture on day one, what we discussed was basically about the data because the FDP is about data science. So we tried to discuss, let me switch off my video. Yeah. So if you remember what we did was we searched what on Wikipedia what is data science, and this is what Google says. A screenshot you can do it yourself. That data science is basically a foundation of mathematics, statistics, so and optimization algorithm. So whatever we consider that it's a computer science or IT engineer field. It's not like that. It's more towards mathematics and statistics. We also discussed how data science or what data science basically means. You are converting your data into an information by applying some science to it. So, and we discussed that how small data analysis can help people increase their sales. So this was basically a diagram which shows that it's a combination of computer science, mathematics, business knowledge, etc. Uh, then we discussed in that data in different forms, and I'm sure uh, this I discussed in the first day because I knew that during the 1 week you will be having a lot of lectures wherein the handling of data will be done, and I could see the sessions handled by various expert people. They handled Excel sheets, they handled videos, they handled audio data, image data. So yesterday there was lecture on GAN. Today also you will have a very good lecture from Dr. Sanjeev Malik, IIT Roorkee at 2 p.m. today. So it was about different data. And then we discussed one interesting case wherein we said that data is in two forms, structured and unstructured. And we said that in unstructured data, it is difficult to, deal with unstructured data. It is difficult to analyze. But at the same time, we say that, the social media, uh, tweets, Instagram posts, they are unstructured data. But still, there are many applications or much of research which is focused on these Instagram posts and the tweets, etc. Then how they are able to do that? Thereon, the concept of textual data analysis came in, wherein we are trying to find the context of the data rather than, just using some keywords. I'm sure in the last 1 week you must have come across a word called bag of words, a terminology called bag of words. Just hold on. A bag of words. It is a very commonly used term and a concept in, machine vision, machine learning, computer vision, data analytics, wherein there are certain words, you put them into a bag. You can easily relate to that. Basically, you are making a grouping of it. And the moment any word from this particular group comes in, you easily categorize them based upon whatever target sections you have: positive, negative, depressive, and so on. This is how we categorize the data, the types of data, and then we discuss what a good data is. I think that was the last slide, and we stopped over there. So today we'll talk about data science and artificial intelligence. So I just wanted to give you a quick brief of what we had discussed in the last class, in the last talk. And during that talk, we also saw how Google Translator works and how this contextual analysis is being used. So now again, when I start with today's lecture, which is data science and artificial intelligence, last time what we did was we did a Google search of what data science is. Today we will do a Google search of machine learning. Now, if you look at this machine learning, again, there are certain, terms that are highlighted. You can see computational statistics. Look at the second paragraph. Computational statistics, mathematical optimization, making prediction using computers. So you will see that even in the machine learning part, it is not purely IT or computer science. Again, the mathematics and statistics is coming into picture. If you see what artificial intelligence is, it is reasoning, knowledge representation, planning, learning, natural language processing, perception, And then again, you have statistics, probability, economics, computer science, psychology, linguistic, philosophy, and many other fields. So we can see that AI, matlab, I mean, what we say that it's a computer science or IT related field, it's not that. It is an interdisciplinary kind of thing. The way it was there for data science, the way it was there for this machine learning. Similarly, for AI, it is basically amalgamation of various fields, which primarily includes your statistics, mathematics, optimization techniques, and even when you talk of optimization, it's again mathematics complete. I am sure many of you are working in AI and data sciences. People who are working, they can see that even for optimization, when we talk about optimization algorithms, there are certain algorithms which have been designed after so much of research, and there are certain algorithms, optimization algorithms, which have been basically adopted from nature, and they have been formulated mathematically. Like if you talk of about swarm optimization or an ant colony or honeybee. So what the pattern is basically, you can see that whenever the birds are flying during evening time or during morning time, you will see that they are making a V out of it. So one will be the leader and the others will be the others will be the followers, and they have a strategy to work upon. And you will see, if you obviously they are birds, they just fly away very quickly, but researchers have done an analysis that the leader is not, I mean, the bird who is at the leading position, he or she, that bird is not there permanently. It changes position because the one at the front has to face a lot of wind pressures. It's not possible to, a one person, a one bird to handle all that. So the first position is being swapped between the flock frequently. Similarly, when you see and you put a small sweet piece somewhere, some ants will come, and if you look at them very, we cannot watch birds how they are flying when they are changing position. But yes, it is easier for us to observe the ants, and you can see that if there is a piece, they will make a path from the source to the destination. For them, the source is the sweet piece, koi bhi mithai ka piece, and maybe the source, you can take vice versa. The source can be a sweet piece, and the destination can be their own home or wherever they want to take it back. You will see that all the ants, they follow the same trajectory. It's not that one is going from the right and the others are following the left, or one is going from making a C and the other is making a U-turn. It's not like that. They follow the same path. Ek ke piche ek, maybe 50, 60 or 100 of ants, they go. And whenever they are crossing each other, you will see as if, it's very interesting to watch them as if they are talking to each other, ek dusre se kuch kaha, and then they, went on to their path. So all these things have been, analyzed, and they have been put it into mathematical models, because what ant searches is the path that ant goes is an optimized one. It is based on certain set of assumptions, or maybe a fallback kind of thing. So that has been modeled, and they make our optimization algorithm. So again, it is all mathematical modeling, and this is what AI, machine learning, data science, they, they have the background of all these algorithms. So when we talk of about AI, there are three different legs. One is the AI algorithm, second is the computing horsepower, and third is the data. It's like three legs of a chair or a table, and you require all the three legs for a chair to stand. Even if one of the leg is gone, that you cannot sit on that chair. So it's something like that. You need a good AI algorithm, which will give you the desired output. For example, if my algorithm is about classification, or maybe yesterday Dr. Subramaniam Murala, he was talking of image reconstruction, adversarial networks he was talking about. So he was showing a target figure and a figure that has been generated. So in the target figure, you could see that the scarf of that lady was very good. It was there was some kind of embroidery or whatever you say. But when it was generated through a AI algorithm, it was not that clear, or it did not had that finish. So the algorithm has to be very good. So it has to be, improved upon based upon the learnings or based upon the shortcomings. We can't be, we can't get the very good or the best algorithm right in the first run. It's always effort, effort, and effort. So you develop one, you will have certain shortcomings. You make architectural changes, and then you come up with the second one a little better. More architectural changes, better results. Little better, so on and so forth. You want an AI algorithm. Secondly, you want a computing horsepower, because till the time that AI algorithm does not have a computing power with them, they can't run. In the last 1 week, you have discussed about basic AI algorithms also. Dr. Ashish, I think he was from Triple IT Gandhinagar. Dr. Ashish, he discussed that he was working on AI purely and not on the deep neural networks. But the person sitting next to him works on deep neural networks. Why Dr. Ashish is not working on deep neural networks? Because it requires a lot of computation capability. They require high-end GPUs, and it's difficult to to have those GPUs. If I just do a small, comparison sort of thing, a normal system may cost you about 50 to 60,000. बहुत अच्छा ले लोगे तो 80,000. But when you talk of a system, in the sense, I mean a laptop. But if you talk about a GPU with these deep neural networks, they require GPUs, graphic processing units, which are dedicated for analysis of these deep neural architectures. And why do we require GPUs? If I come back a little, it's basically the difference is when we are talking about AI, we are dealing with small set of data. 15, 20, 30, 40 images. But when we talk about deep neural networks, we are working with, thousands of data. In the last session also, I discussed, whenever we are talking about deep neural networks, we talk about 1,000, 2,000, 3,000, 4,000 data. And that also we say that it's not sufficient and we need to augment it. We augment that data so that we can have more and more data. In Towards the end of this session, I will discuss one of my work, which is basically on fish species classification. It is being done with one of my research scholars in underwater scenario. Therein, we had a data size of somewhere around 27,000. It is 27,000 plus. So it has a data size of 27,000 plus images. So when we are talking of 27,000 plus images, obviously we require a lot of computation power. Your system cannot handle 27,000 images at one go, and at the same time, whenever we are talking of applications, we want instant results. You don't want your phone to whenever you are pressing the numbers, you want the uh, call to go instantaneously. Similarly, whenever you are attaching and you are sending an email with an attachment, and it has an attachment. The moment it is attached, immediately you are very happy. But when it takes time, you get irritated. So you want the things to be faster. When it has to be done faster and processing of 27,000 images, you need good horsepower. A simple laptop of 60, 70,000 cannot handle that. It will crash immediately. So what we require is GPUs, just because we are handling more data in deep neural networks. So when you're talking of GPUs, uh, normal laptop costs you about 60 to 70,000. Better ones will cost you about 90,000. But when you talk of a GPU laptop does not come any less than 1.5 lakhs. It will be 1.5 to 1.8 lakhs plus. This is the minimum that I'm telling you. And the moment you improve upon the specifications, the cost will go much higher. So these are and if you talk of a GPU desktop, it is even much higher than the laptop. So these are and most of the GPUs nowadays people prefer GPUs from NVIDIA. So these are the three legs of artificial intelligence. We have AI algorithm, and then we have data. Based upon data, what architecture, how much data do we have, and what architecture we are using. We can decide upon the computing horsepower that we require. We require a normal CPU or we require a GPU. So this is about data and AI once again. It says that by the end of 2024, we are now in 2021. 75% of enterprises will operationalize AI, driving a 5x increase in streaming data and analytics infrastructure. What it says is that by the end of 2024, if you look at it, we are dealing with so much of data. And in this COVID times, when everything is being online, the data has increased manyfold. Earlier, many things we were doing in physical mode. Now all has been done online. When it is online, that simply means we are streaming lots of data that includes audio, video, text throughout the day. Earlier things used to be in physical mode, but now for everything we are sending a mail, we are having a Zoom call, we are having more of telephonic discussions, which we used to do in physical mode, face to face. So instead, and all the companies, all the corporate sector, all the government agencies, they're looking for having AI that can help them in the data and the analysis of data. And I guess most of us, we belong to, educational institutes, barring a few who may be from research labs or maybe schools or whatever organization. So we can see that in day-to-day life, we are dealing with so much of data and so much of analysis to be done. For example, I'll just take a simple example. That, for example, I am designing a syllabus and I need to update that syllabus. So one way of doing is, the easiest way will be I'll take up the syllabus and I will just modify a few text bits over here and there. I mean, I will just, you know, uh, say that the syllabus has been updated. But if I go to data analysis part and if I apply, a little mind into it, what I'll do is I will see how the students has been doing for that particular subject in the past. What are the placement statistics? Do the placement into the company interviews, they ask for this subject or not during the interviews, whether this particular subject is of industry demand or some research is being done over it. And let's suppose if no research is being done over it, is it the foundation for some latest topic? So if I take all those factors into account, I do the analysis and then I come up with a a new updated syllabus. That's going to actually help out the students in a much better way. But all these things, what they require is a data analysis. If you talk about a faculty, or even if you talk about me, and if you ask me to, to go every nook and corner, I have to go to the interviews, I have to, see the industry demand, I have to check the results of last few years, I have to check the interest of the students or maybe 10 other things, then I will say it's a lot of work to be done just to update one syllabus. And all this requires, gathering the data, cleaning it up, and then analyzing it, and then concluding it. It's very difficult, too much to handle. Just I will say that it's too much of work to be done. So not my cup of tea. But if there are certain, agencies or certain companies, or maybe it's a part of the ERP system that our institute is having, that after all those analysis, I have to just select the parameters. Okay, for deciding upon this, the parameters to analyze are 1, 2, 3, 4, 5, and 6. And based upon this, some automated thing gives all the entire data analysis and send me the suggestions. It is a lot more easier for me. I will be able to update the curriculum in a better way, which has been, based upon certain facts and figures. And I don't need to, go to every nook and corner to fetch the data and, and analyze it myself. So what we are expecting is that by 2024, AI will be there and there will be 5x increase in the data analysis part and the infrastructures will be developed according to that, and that's going to happen soon. So we discussed about data science, we discussed about AI. Now what we can say is, if you look at this diagram, uh, we have AI, which has human intelligence exhibited by machines. And this AI is a bigger set, which has different subsets. For example, we have machine learning, we have deep learning. And you can see that there are certain applications which has been put with this, just to give an example. For example, when we talk of AI, it can be, Amazon purchase prediction. you you just when you're doing window shopping, you search for a bag, and all the bag options keep coming to you for the next 1 or 2 months. So that is an example of application of AI. You have smart email capacity. Excuse me. So you Amazon purchase prediction was one. And second is smart email categorization. The way we discussed that your mails are being categorized in primary, secondary, junk, spam, and you're sending them to bin and so on and so forth. So that is also an example of, uh, artificial intelligence. Then you have machine learning. An example of machine learning is Google Maps speed of traffic, which I think all of us are using very extensively before starting from our source to to the destination. We just see the Google Map, which is the right way to take, which is blocked and which is clear. So there are times that instead of the shortest route, it gives you a clear route option. So you may have to travel for 25 kilometers, but it will be like you will be sailing through it easily. Otherwise, maybe a 9 or 10 kilometer distance may be completely blocked and the time taken will be more. So it's an example of machine learning. the Facebook facial recognition. It tags people automatically. Similarly, a Netflix video recommendation. You see a video, you ask for a video, kids video or animated video, it will start recommending you. You see one or two animated videos, it will, I told you that my YouTube channel, if I open my YouTube, what I see is all animated videos suggested to me. It's not that I am watching these animated videos, but I never open my YouTube for a video, but my kids keep on watching them, need a daily watch time. So that's how these recommendations, it is written Netflix, it even, refers to YouTube also. So they recommend. Third, we have a third subset is, or maybe you can say the smallest and the latest addition to this AI set is the deep learning. And we're talking of deep learning with time, so many things are being added to. 2 days back, we were discussing with, Dr. Ashish about the explainable AI. And yesterday we have shared his brochure to you people on the group. So whosoever is interested can join that particular session. It's just a 3-day session. So the latest addition over here is the deep learning, which has self-driving cars. Speech recognition is there, robotics is there. Why do they require deep learning instead of machine learning? So if you look at it over these self-driving cars, speech recognition, and robotics, they require a lots and lots of data. And even for the self-driving cars, or which is also known as autonomous cars, uh, they require a lot of data because one, the training on lot of data, because one mistake from that self-driving cars, because you are not in control, the car is being driven automatically by the machine. So one simple mistake of the machine will not cost anything to that machine because it has some cost which is associated. वो तो हो गया. But it will cost the life, it may cost the life of a person who is sitting inside the car and maybe the person's on the road. If there is a small simple failure, it can cost many lives. So when you know that the cost of mistake is huge, then you need to be sure, and doubly sure. So to have that doubly sure figure that it's okay and self-driving cars can be put on roads, then you have to train it in lots of data in many scenarios which can happen in real life. So for training of lot of, because you require deep learning for that. Then you have speech recognition and robotics as a part. So when we talk of speech recognition and robotics, again, can anybody tell me an application of speech recognition? If you can just write in the chat box. Okay, is Alexa an example of AI or ML? See, there is one question in the chat box. Is Alexa an example of AI or ML? What do you think? What it will be? AI. Okay, see, it can be an example of AI any day. Because if we talk about machine learning or deep learning, they are in any case a subset of AI. So even if you talk about deep learning or machine learning, they are a subset of AI. So Alexa is a very good example of AI, and we can call it AI. At the same time, when we talk about, the reliability of Alexa or any such, machine, if you want to improve upon the reliability of that, you need to train it on lot of data. So the moment the training on lot of data comes in, it is categorized into deep learning. So right as of now, you can take it as an example of AI. Okay, can I have some, examples wherein speech recognition is being used? Okay, one can be just one can be Alexa. Alexa is an example of speech recognition. And anything Google Assistants, right? Yes. Okay. Google Assistant is an example of AI. Alexa is an example of AI. And one example that I would like to add over here is the banking sector. If you just, speak, call any bank service, any bank credit card or for your debit card, there some of the good banks, what they have done is instead of putting a password or a pin, because every time you have 3 or 4 accounts, and for every account you have a different password or a pin. Obviously, these are the bank accounts. You cannot keep them safe. Same. So Cortana is a good example. And then they have done is they have their softwares which say you speak this in your voice. It recognizes. Let's suppose if I say that my password is Google Assistants, for example. So whenever I'm calling my bank, I'll have to say my password is Google Assistants, or something like that. It's a random sentence that I'm making. The software in itself will say you speak this, and they will recognize whether it is you or it is someone else. So by that, they recognize and they opens the portal for you. So this is an example of speech recognition. Again, over here, different people have different voices. They have a different, tone of saying the things. So even if I talk about deep learning or maybe a small little sentence, I can speak in different tones. And there are times, for example, today I am feeling a very choky throat. So the voice may not come up that the way it should have been in normal circumstances. So whenever we are talking of deep learning, it makes sure that it trains your system for every different scenario. It will slow down the tone, it will slow down the pitch, it will maybe do it at a little different frequency. कभी कभी दबी आवाज में, कभी अच्छी आवाज में. So it will give all those scenarios and it will train your system in such a way that even if you give a minor variation of your actual voice, it will try to give you the reliable, classification, whether it is you or someone else. So that is why it is for deep learning, because if the speech recognition is being used in banking sector, again, a small little mistake may cost a lot of money to the account holder. Similarly, speech recognition is very much being used in legal cases. So just hold on. I'll have to then take a walk. Yeah. Mr. Kishore has written, I wish to enable online international transactions on my credit card. Then I'm taking the help of that bank AI help. It has become very simple now. Yes, that also, justifies what is written in the previous slide, that 75% of the enterprise will operationalize AI, driving a 5x streaming and 5x increase in streaming data and analytics infrastructure, because the moment corporate sector or any organization go for AI, by default it means a lot of data streaming will be there, a lot of data analysis will be there. So you can see the operations in your everyday life. So this is data and AI put together. When we talk of it, Sakshi, I've closed my chat window. In case there any query or any suggestion comes up, you can please interrupt me in
Sure, ma'am.
between. So this is the role of AI. We have a training data, we build the model. Again, this training data can be huge or it can be small. Based on that, you can divide your AI architecture into shallow or deep neural network. And what we do is you have taken data, you have built the model. Now what you do is you take a new set of data. Whenever we are doing this deep neural things, we say that we have training data, we have test data, and we have validation data. So you take a new data, which is entirely different from your training data. Use that new data on the model that you have developed, and you get the prediction. And you see whether it is, the actual output you should be receiving or it is something else. If it's not the actual output you should be receiving, then what you have to do is you have to go back to the model setting, and you have to change the architecture, do some optimization so that you get the actual output. For example, it's a binary classification problem of identifying a 1 and 0, and you give 1 as input, you want 1 as the output. And let's suppose it does not give 1, it gives 0. So that means your architecture need changes. Some of you might be thinking identifying a 1 and 0 is very simple. How can it be a AI problem? It's like you go to MNIST dataset, which is available online. And that reminds me, I'll go back to one more point. MNIST dataset, it is available online. And you will find that even those words, it is basically about a textual data. If I write A, I can write it in a different way. Sakshi can write it in a different way. Archita can write it in a different way. If I look at the name Abhishek, Adarsh, Aditya, Naresh, Veena, everything can write A in a different way. And the moment we talk about B, similarly, there can be 10 or 20 different things. And if we talk about words, for example, if I say bat or cat, or maybe my name is Nidhi. So there can be 50 different, handwritings. 50 different handwritings. So it is easy for us as a person to, understand what it is written because we are trained like that. But if we talk about an AI algorithm to, uh, read that word and type it in the legible handwriting, legible words, then it depends how your AI architecture has been developed. It may, it may give you the actual output, or it may give you the output with a little, deviations or maybe little spelling mistakes. So we want it to be actual output without any spelling mistakes. For that, we need to keep on, improving our AI architecture, and we want that thing to happen. That is why, this AI. If we talk about the origin of AI, it is basically we are trying to give the intelligence to the machine the way humans are. Humans are more intelligent than AI. Again, on my this statement, there has been a lot of debate that's going on around the world because human is more intelligent and we want our machines to be intelligent. That is why we are trying to, develop machines that can behave like humans. But now what has happened is we have made machines so intelligent that there is a threat that they will replace the humans, which in certain cases it's been happening also. But the end of the day, the humans have been gifted by God with the intelligence and with the IQ level. It is very difficult for a man to replicate that gift into a machine. So it has its own limitations, but at the same time it is, improving with the time and giving outputs. If you talk about that human bot who has won the debate, it was there in news 3 4 years back. And recently, if you would have read the newspaper, I think 2 days back, it was an article in Times of India. In the US, somebody has applied for a patent, US patent, and that somebody is not a human being, that somebody is a machine. A machine, a computer has applied for a patent. Now, it is under debate whether a patent is to be given or it is not to be given, because ideally a patent applicant can be a human being. It cannot be a machine. You cannot give a patent to a robot. You cannot give a patent to a human being. But nobody thought of this scenario. So the patent application or the patent application, the one we submit at the time of submitting the patent, it does not clearly specify, because nobody thought that a machine or a robot will ever, file a patent. So that's been under debate since long. And 3 days back, the verdict has come, and US court has denied that a patent cannot be given to a robot. So that is also there. It is a very good example of, again, a deep neural network or AI, wherein you are making machines so intelligent that they are filing a patent. Yeah, one thing I would like to come in between while talking about MNIST data set. In the 2 days back in the lecture of Dr. Ashish, somebody was talking about developing their own data set and working on that. I don't know whether that person is over here as such or not. But see, whenever you're working, you're developing your own data set, it is always encouraged that you make your own data set, work on that data set. But whenever you go for research publications, this is what my experience is. Even, the 90% of the people sitting over here, they must be researchers. So whenever you are, submit a paper, it may get rejected. I have seen the rejections just on the basis that the comparison part is not done on a standard data set. Whatever data set you have taken up, analyzed, is the one developed by you. How can you compare it with, the state of the artwork? So it is not fair. So that point was well taken care. And we also know that every data set has their own limitations, has their own pros and cons. So if you're creating your own data set, please work on that. But while submitting the paper, make sure that you are comparing your results with a standard data set. And if you have created your own data set, please publish it in the form of a paper and put it for open for use, so that slowly and steadily it becomes a standard data set. And secondly, there is a website by the name kaggle.com, wherein you will find a lot of databases. It has lots of data for text, audio, video, uh, data. Your handwriting data is there. If somebody wants to work on the handwriting, scriptures are there. Even this COVID-19 related data is there. So there are numerous data. If you're interested in any of the fields, you can go to Kaggle. Most of the databases over there, they are open in nature. You just download them and you can start working on that. And certain databases, if they are, they are not completely open, then you have to just request the researcher. They are able to provide you with the data set with a certain set of terms and conditions, which mainly includes that you will not be using it for any commercial purpose. And whenever you are using this data for research publication, you need to cite the paper of that particular author, that particular person who has published that data set. So these are the main terms and conditions. So you can go to Kaggle, and I'll just put it in the chat so that it is available to all. Kaggle. You search any data set on Kaggle, almost 99% data sets they are available for you. So coming back to this, in the last slide, we talked about training data, we build a model. Then we have new data, we call it a test data. We apply this data on the model, we get the predictions. If the predictions are not the way we wanted, so what we go is we go back we develop the model feedback loop, update training data, update model, and get new predictions. So you add more training data, you make architectural changes, do the training again, and then get new predictions, which may be nearer to the, the actual output. What problem arises when the data gathered is poor quality? So I think we have talked about it in the last session itself. So I will just quickly cover it. If your data is not correct, the output that you will get will not be completely reliable. It may give erroneous output. Secondly, the productivity of team depends upon the data. If the data is not good, in the last session also we said that 80 to 90% of the time is 80 to 90% of the time of a data analyst or a data scientist goes in cleaning and gathering the data. So because if your raw material is good, your output is going to be good. If the raw material or the data is not clean or it is not prepared well, then your time is wasted and the output that you get will not be reliable. Data cleanup is very tedious, we all of us know. So I'll just quickly wrap up this slide. And then we have data collection. It is like data acquisition, आप कहाँ से कर रहे हैं, whether it is a Google platform, it is an IoT application, or it is some data gathered through Google Forms. What is the reliability of that data? Third is strict policies and ethics. Why it is written over here? Because I told you that for Kaggle, you will have many of the data sets that are open in nature. You can easily download them and start working on them. But there are certain data which does not fall under this category. For example, we have been working with a project, research project with AIMS Delhi, and we have gathered the data from AIMS Delhi. It is for a gastro department, and these are the images of few patients. So for them, it is a confidential data. They don't want patients' data to be out in public. So that is a private data set. The ethics of AIMS Delhi or the medical fraternity does not allow them to be open with the patient's name and all. But yes, when this data, from this data, if the patient's name and the personal details are deleted, then this data can be made public. But again, for that particular thing, we need to take proper, permission from our university and the AIMS Delhi. So the policies and ethics need to be, considered while making any data public, private, or closed. And then reusability, whether the data is reusable or not. It is stored in a common format. You can have multiple file formats for the storage of data. Then you need to see whether they are stored in a common format or not. Again, I'll just quickly wrap up with this. While you're preparing your data for AI applications, you will have to acquire the data, you will have to clean the data. And what does mean by data annotation and data wrangling? Whenever we talk of about data annotation means that classifying one as one and classifying zero as zero. For example, it is very easy for us to classify one and zero. But if I talk about medical data, for example, the data set that I'm talking about, since last 1 year we had that data, but we did not know what to do with that data, because what that data is about, the small abdomen within the human body. And within the human body, it's not like the way, in our 9th and 10th standard, we used to see that there are the two lungs, a food pipe is going, the abdomen is there, a small little stomach and heart is there. So it's not like that. It's basically small little area which has lots of blood, veins, arteries. We do not know whether this area belongs to near to the food pipe or near to the lungs. And what is this image depicting? I'll just share another slide so that you have an idea of what data I am talking about. Give me a moment. I hope my slide is visible to you.
Yes, ma'am, it is visible.
Yeah, see this kind of data we got from AIMS. So if I ask you which part is this of a human body, I guess nobody of us can tell. And nobody of us can tell whether they are, they look normal. If I have to classify it, whether they look normal or they are abnormal. Can Sakshi or Rachita or anybody from the participants can tell, please? I will just open my chat window so that I can see the responses. Anyone who can.
Ma'am, is this the lower part of the eye? Just guessing.
No, it's not the eye. It's from, the small abdomen. It is within the human body.
Okay.
It is within the human body. It's not related to eye. Sakshi, I'm
Okay.
not able to see the chat window. Okay, from here I can
I
see.
can
Yes,
read the.
yes.
Yes, ma'am.
Any
Somebody has
guesses?
written. We have got one answer from Sujatha
Joint,
Upadhyay, ma'am. Joint.
joint. No, no, no. It is from the human body and from the, upper part. From maybe the throat till the, abdomen side. That's what, I am talking about. Till the time we had this data for 1 year approximately, but did not know what to do with this data. We could hardly analyze it or understand it. Then we have to request the doctor because whenever we tell him, because they are from AIMS Delhi and one of the best research institute of India. People across the country, if it is not getting solved anywhere, they come to AIMS Delhi and appointment मिलने में 3-3 महीने लग जाते हैं. So if we talk to the doctor कि सर इस डेटा को आप समझा दीजिए, सर वो डेटा तो दे दिया मैडम आपको, सर डेटा तो दे दिया, उसका करें क्या? Somebody is talking about skin. No, I'm talking about within the human body. It does not have any skin within the human body. It's the outer layer of the body. So sir वो डेटा तो समझ नहीं आ रहा what is to be done, but they are busy people. So it took us 1 year, to get the in-depth of the data. Vocal cord. No, it's not vocal cord. So it's not vocal cord. And to tell you one thing, although we are working on this, even I cannot tell this is which part of the body. I cannot tell whether it is the vocal cord or it is the throat or it is somewhere else. I can show you, lot more figures like this. I have plenty of them. I have almost, if you talk about distinct images, there will be there are 9,000 images. If you talk about, whenever there is a video, we can see that the subsequent frames, they are similar to each other. And after a few frames only, you will find some change in the pattern. So if I talk about the subsequent frames, I may have 60 or 70,000 images. So I am definitely working on deep neural networks for this because the data size is huge. I cannot handle it through a normal neural network. So come back to this data. I will show you one or two more figures. See, this is the data. This is how we have augmented it. So this was the first row, I'm in the top left. is the original, and the augmentation is basically you are increasing the data. So how we have increased it, we have given the horizontal flipping, vertical flipping, the rotation we have given, we have rotated it by a few, some degrees angle. So you will see that if the first image is like, all brownish on diagonal ends and a yellow bright portion like this. So it will be in all images, but in different, at different angles. So this is basically augmentation. You may change the brightness. You will see that in these four parts, this yellow part will be a little noisy or maybe darker color than this. This is basically augmentation, that your basic image remains the same, but it will have some variations. So your deep neural network will be trained for all the images. For example, it is trained for my voice. I can understand that on Monday my voice was different. Today I'm feeling a little difficulty in speaking and I have to take a water break again and again. So the deep neural network will be trained for all the variation, all the possible variations. Similarly, if I see these are all the original images and the augmented images. This is the original image and then augmented image. आप उसको 90 degree से flip करते चले जा रहे हो. This is how we do augmentation. I have more images if you talk about it, but certainly I cannot say which part they belong. Why I cannot say? Because whenever you are working on a data set, either you work on classification, right? Whether they are normal or abnormal. For this, or you work on localization. Okay, which part is this? As of now, what we are working on the project is not the localization. Which part is this? Because that requires a lot of expertise and knowledge from the doctor side. I need to sit with the doctor lot many times, consider their human anatomy, how it looks, how uh, the variations can be there and how to identify. So somehow when we were working on this and this COVID thing happened, so everybody, even if we are, we are ill, we are not going to the hospital. So we have also stopped visiting AIMS for, for that understanding part. But yes, we are working on the classification. So looking at these images, I can say whether it is a normal image or it is abnormal image. For example, if I talk about image 1, it may seem normal to you, but no, it is not. Image 2, it may seem normal to you. It is not. It has this, white mucosa over here. Image 3, it may seem normal. You can say that it is a human fluid, but it is not. I'll just enlarge it a little, put it in F5 mode, but it is not, because it is not human fluid within the body. Along with the fluid, there is some depth. If you look over here, there is some depth that has been over there. So it is not. Our job is to make that algorithm or the deep neural architecture so intelligent that the doctor don't have to, see at the picture and say whether it is normal or abnormal. Our algorithm should be able to tell them these are the abnormal images, and now the doctor will say कि इसमें मिकोसिया है या इसमें एंजियोएक्टेसिया है या पॉलिप है या कुछ और चीज. There are n number of malformities that can happen within the body, and we were kind of when we were, I and my team were discussing with the doctor, we were just shocked to see कि भाई ह्यूमन बॉडी के अंदर इतना कुछ भी हो सकता है. I mean, we were actually shocked. So these are the kind of images, and I forgot where we started actually. Yeah, we started with data annotation. So data annotation se start kiya tha, and we came over here. So I said that for 1 year I had this data set with me. I did not know what to do till the time the doctor came and explained me what does this data means, what is normal and what is abnormal. So the annotation part has to be handled, and it has to be handled by an expert person. It has to be handled by an expert. person. I cannot do the data annotation for a medical image data set. But yes, a doctor can do. I hope this slide is visible to you. So
Yes, ma'am.
so the data annotation has to be done, and based upon when we started with data science, we said that domain knowledge is one thing. So we had the data, we had the domain knowledge of AI and deep neural networks, but we did not understand the data. We did not have the domain knowledge of the data in hand. So we wanted that. So that is why the data annotation has to be done, and the doctor has to tell these are, and not only tell the AIMS doctor, he has to sit down with us and manually with those 50,000 images, they were classified into different folders. These are normal, these are abnormal, these belong to polyp, these belong to mucosia, this belong to angioectasia. So, and these are the bleeding images. So all these things has to be done by if a person has a domain knowledge. And tell you one thing, if I talked about bleeding is such a difficult thing to handle, because if you just look at it as a layman, within the body, what we say, it's all veins, it's all human flesh. Within it, fluid is there. So veins ka color is red and the bleeding is also red. Then how will you identify whether it is a bleeding? And the doctor has to see if it is more amount of bleeding, anyone can recognize it. But the doctor's expertise come when it is just the start of bleeding. The bleeding has just started. Us time what we could see in the images is it simply looks like a vein going on. Veins are also red in color. जो simple अंदर हमारे synapses होते हैं, they look like red only. So I and my team, we could not discriminate between a vein and a bleeding. But the doctor told us, no, this is not the vein, this is bleeding. So that is the expertise which needs to be there. And that is why you will see that there are many medical domain papers. You need doctors with you. You need doctors with you. So the annotation part is very important. If the annotation is not there, for example, उस bleeding को हम तो classify कर देते, it is a normal image, but the doctor classified it as a bleeding image. So अगर हम उसको classify ही initial stage पे गलत करते, तो our results would not have been reliable in any case. हमारा accuracy नहीं आता. So annotation has to be done very carefully. Then we have data wrangling, that whatever data you have, you should be able to show that data in a very clear and understandable manner. It should be easy to access and analysis. जैसे वो structured or unstructured data का difference है, that unstructured data is difficult to handle and analyze, and structuring makes it easy to analyze. So you have to do data wrangling so that it is easy to handle. I need a 5-minute break. My even water bottle is completely empty. I'll just come back in 2 minutes. Yeah, back. I think we can start. This again we have covered a lot many times. Data transformation, visualization, processing, and augmentation. I told you about the augmentation also and showed how augmentation is done. Okay, then how much data is enough? Again, it is shown with the help of a graph, but however, we have covered it many a times that this is the amount of data and this is the performance. The traditional machine learning uses little data, and then we have shallow neural networks, medium neural networks, and deep neural networks. The moment you increase the the amount of data, the performance for you, if you can look at these curves for a traditional machine learning data, even if your data is, look over here, at the x-axis, there is some threshold point. If that particular threshold point reaches, the performance stabilizes. After that, it is immaterial whether you are having 100 samples or 200 samples or 500 samples. There is no, increase in the performance. For shallow neural networks, the amount of data is required is a little higher to reach that, threshold. So let's suppose if this point is somewhere around 50 samples, this may be 150 or 200 samples, and the performance stabilizes after that. In case of medium neural networks, just hold. In case of medium neural networks, you will see again the amount of data required changes. And in case of deep neural networks, it has very low performance, even lower than traditional machine learning algorithms. If you look at the x-axis, the traditional machine learning algorithm, for example, is giving good result over here. Sorry, over here at 50. The deep neural networks gives lesser performance at 50, and it gives almost the same performance when the samples have been increased to 200. And the moment you increase the number of samples, the performance of deep neural network reaches at a very high level. And that is why you will see that when you are talking of traditional machine learning algorithms, the performance or the accuracy metrics that you get are 70%, 80%. But when you talk of deep neural networks, you will get 90% plus accuracy you achieve. You achieve 92, 93, 94, depending upon how you are training and testing and what kind of architecture do you have. So, but the point is they require a good amount of data and great computational power. Now the problem comes in, let's suppose you do not have sufficient data. You have insufficient data for deep neural network. What is to be done? I think yesterday you have already discussed it in the lecture of Dr. Murala, that either you can use transfer learning, you can use data augmentation, and you can use GAN. Data augmentation slide, I have shown you how from one single image you are generating 7 more images. So your data becomes, one image is transformed into 8 different images. So let's suppose if you have 500 images, it will automatically get converted into 4,000 images. If you have 100 images, it gets converted into 8,000 images. So that is how you can do it. Or transfer learning is an approach wherein there is a deep neural network. In a general neural network, or a deep neural network, what we do is in a CNN, what we do is we train the data on the same set, and we keep a different 10%, 80-20 का ratio या 75-25 का ratio हम लेते हैं. For 75% of the data, we use it as training and 25% as the testing. But in transfer learning, what happens is because we have insufficient data, we train the data on a different data set, whichever is available to us. The architecture learns, the model parameters get fixed, the weights get fixed, and we give a test data which is entirely different from the training data. So that is basically transfer learning. We have AlexNet, VGGNet. They are mainly used as a part of transfer learning. Then we have GAN. In GAN, what we do is we give the target image and it generates the architecture automatically generates images similar to that. Yesterday I discussed that example in my session this time also, that Dr. Murala told the target image and the image that is generated by GAN. It was almost similar, difficult to identify, but there was only a small change in the scarf of that particular girl. So this data analytics, I'll just skip this slide because it's something that I might have discussed while uh, talking all this. Then there are different stages of analytics: descriptive, diagnostic, predictive, and prescriptive analysis. For example, descriptive analysis, which says what happened. In diagnostic, we say why did it happen, whether it is if you look at this graph, this will tell you everything. When you're talking about descriptive analysis, you have an information and it says what has happened, it describes the data. When you are talking of diagnostic analysis, you say why did it happen, diagnosis there. Predictive analysis is what will happen. For example, in one of our research problems, we are working on predictive analysis. Uh, in predictive analysis, for example, in case of bleeding only, if I talk about this example, the images that I showed you, that the start of bleeding is difficult to identify. It was difficult for us, but the doctor could predict it, that it is the start of the bleeding and slowly it will increase beyond the point of control. It will slowly increase to the point of, so he predicted it, but we could not do that. So we have to depending upon the application or the requirement of your research problem, you will have to decide whether you are working on diagnostic, you are working on predictive, or you are working on prescriptive analysis. Prescriptive analysis, a very good example I can take in the from the last session that we discussed, that we want to increase the sales of a particular shopping mall or arcade. So what is to be done? They put diapers next to the beer bottles, or sales badana hai. So in our shopper store, best side, lifestyle and all, you will see 100, 200 goodies or 300 goodies, 300 worth rupees, 300 goodies kept near the billing counter. And it may be like a toy shop next to the puja pandal, because if you're going to a temple, you ought to buy a thali for the Bhagwan. And when you are buying that, the kid along with you will ask for a toy. You may postpone it कि बेटा अभी तो मंदिर में जा रहे हैं, let us come back and then we will buy. And you may forget, but the child will not forget, because inside, when the child is within the temple, he or she will not think of uh, wishing the god. He will think, let's go out and buy the toy. His mind will be constantly on that toy shop. So these are the prescriptive analysis wherein you analyze what is to be done, how can we make it happen, what can be done so that the sales are increased, how can we make it happen. So these are the popular application. I'll just skip it because we have already done it, discussed it. Medicine, predictive modeling, media, and so on. To sum up, we have to collect the data, we have to move and store the data, we have to transform the data, we have to aggregate or label the data monetization, annotation, sorry, data annotation, and then we have to learn and optimize the data. And if you look at this, all these things, the basic is collection of data, which may be from, it can be a user generated content, it can be machine generated, and the reliable data flow. You can just read through the slide and just stop for a moment. So this is again the last slide. We already discussed it, that this AI and data analysis together, they know who are you, who do you know, what can you afford, where are you, and so on and so forth. I will not discuss this, already done in the previous session. So this is all from my side, and I thought of covering a small little part of the work that we have been doing. I discussed a small little part for the medical part that I have done. And there is another small algorithm I'll just quickly discuss, because we have to take a 5 to 10 minutes break also before the next session starts in. Just for your information, the next session is by Dr. Amita Dev. She's the Honorable Vice Chancellor of our university, and ma'am will join for the session at 12 o'clock. I request everyone to be here at 12, and we will start the session now. For now, I will just, in 5 quick minutes, I'll discuss about one of the papers that we have communicated in Springer, and it has been accepted. It's my PhD student's work, and it's not on medical data, but yes, it is on a data that, for fish species classification, and we have handled 27,000 images for that. Actually, there were two. Okay.
Ma'am,
Yes, Sakshi.
ma'am, we have one question from Pooja ma'am. Ma'am, she's asking that please give an example of prescriptive analysis in medical line.
Okay. For example, I was talking of, bleeding only. I'll take that example only. It is just the start of the bleeding. So, prescriptive analysis, how we make it happen. So over there, the question will be how to make it happen कि हमको bleeding रोकना है. So if the bleeding is to be stopped, then either we have to start with the medication, or we have to, take appropriate measures, or, operate the patient immediately. Or maybe, prescriptive analysis is basically, you can also consider that whenever you are going to the doctor, uh, you say, I have some problem in the throat. Okay. The doctor will take an examination of your throat. He say, and he will put a torch and have a look. And he says, okay, it is normal. You take this medication and it will be done. And at times he will say the entire throat is, swollen, or it is reddish in color. You need to take an antibiotic. So this is, the intelligence of that doctor, again the domain. But when we talk this in terms of, medical domain, what we have is we have to train our network for so many throat images. The view that doctor is seeing from our mouth till a little deeper, jitna bhi dikhai deta, we have to capture those images, train our, you know, network, and then you can work it for a prescriptive analytic kind of thing, that using these pictures. So Kaivar, if you remember, if you go to the doctor, he says you have come at the correct time. Had it been 1 or 2 days delay, you will have to go on the antibiotic. So it is just the start. It may be the start of something. वो pinkishness throat में होना शुरू भी हुआ है, which will convert into something, crucial. So that can be prescriptive कि आपको initial stage पे उसको detect कर लो, ताकि आप उसमें दवाई या antibiotic शुरू ही ना करें. That you can take as prescriptive. Thank you. Now coming back to this fish species classification. So we did the classification using machine learning algorithm and using deep learning also. And I will just quickly come to the data set. अच्छा, इसमें challenges क्या थे underwater environment में काम करने में? We all know that images outside in front of us are different, and the moment they are in the water, they are different, because water has lot of perturbations. The light is different, and over we are not talking of a artificial water. We are talking of the images that has been captured under the sea, wherein fish species are there. So these are the fish species that they were there. There were 23 fish species, and we had to classify them into different classification. For example, if this fish species number 2, 3, or 4 is there, and I give an image, my network should be able to classify with which fish is this. So for this, we have worked on machine learning also and deep learning also. These are the data set details. If you look at it, the sample 1 has 12,112 images, sample 2 has 3,593 images, so on and so forth. So it is a completely imbalanced data set. For some samples, you have 12,000 plus images. For some samples, you have as low as 16 images. So it's a highly imbalanced data set. And when if you talk about a imbalanced data set, it is very difficult to train the architecture, because for a particular fish species, for the training part, almost 10,000 images are coming up. So later on, the architecture will very easily identify this Dicyclus reticulatus. But if architecture has only 10 images from this nigroisis, so the architecture won't be trained for this, for that, because for one of the fish species you are giving 10,000 images, for another fish species you are just giving 10 images. So at the end of the day, how will it classify this? The results may differ, may not be that reliable. So that's a challenge. We try to handle that using deep neural, also using machine learning, also using transfer learning also. So for over here, we have did it using transfer learning. So over here, you can see that we learned the feature, the classifier was trained, and after training the classifier, we transferred the features and we gave the test data and we got the output. To be very precise, there were 27,370 fish images, and we used a pre-trained AlexNet for classification of images. This was the small structure of AlexNet that we have developed. An input image, then we have 5 convolution layers, then there were fully connected layers, 3 fully connected layers, and at the end of the day we were getting the output. And in this we have not done any change in the convolution layers, but yes, the last 3 layers we have trained and tested using uh, our the novelty was in the last 3 layers that we have designed. And we compared it with using various deep learning and machine learning algorithms present in the literature. So this is the comparison, and you can see that when you're talking of machine learning, you have 80.14, raw pixel 82.92, raw pixel nearest neighbor 89.79. And the moment you come to deep fish, so the accuracy, just look at the sudden jump of the accuracy. It is not below 92, 93, 95. It is in 98s. How to beat that? And all this is happening because of lots of data, lots of training and testing data. So for our proposed algorithm, the architecture that I showed, we received an accuracy of 99.42, and this work was published in MTAP Multimedia Tools and Applications Stranger. Later on, we developed a app for that also. I will just show you. These are the analysis which were done in between, and I don't know if we developed an app also, wherein we gave this fish as the input. The actual fish name is the amphibian clariki, and the predicted output is the same, amphibian clariki. Similarly, for the second, the actual fish name is Pomectrus, and the predicted name is also same. So this app, you give any input, it had all the images set up. So if our architecture is getting it correctly, it will take the same image from it will give this predicted output it will give. You give an input, it will give you the name of the predicted output, and we can see the actual fish name is same as that of the predicted. So these are the few screenshots Sakshi, just for your information, this work was done in collaboration with your seniors, BTech students and my research student. They worked on this.
Oh, ma'am, great. That's great.
So this is the app those students have developed, and again this is the second algorithm, second architecture. There were two algorithms developed on this, architectures developed on this. For this, we received 98.03% of accuracy. So that's all from my end. We take a 10, 15, 20 minutes break, and we will start with the next session with the session of Dr. Amita Dev. If there are any questions, I'm open to take them. Please write it in the chat box. I think no questions, Aksh. Can you make? Okay.
Dear participants, if you have any questions, please feel free to ask here on the chat.
I think no questions, actually, we can write.
Okay, ma'am, sure. So, on behalf of IGT2W, I would like to take this opportunity to express my heartfelt thanks to Nidhi ma'am for such an amazing session. So, nowadays, data and AI can be used to enable our computers to perform such intellectual tasks as decision making, problem solving, perception, understanding human communication, and many other things. Dear ma'am, we are very grateful for the time and effort you took to share your experience with us. We have learned so many new things from you and we look forward to learning more. Thank you so much for the highly inspiring time with us. Thank you so much, everyone, for being such wonderful participants. And thanks a lot, everyone, for your unwavering attention. We look forward to having you again in our next session. Thank you.
Thank you.
Thank you, ma'am.
Thank you, Sakshi. Thank you, Archita.
Thank you
Thank
so
you,
much,
ma'am.
ma'am.